Question 1. Copy the figures with punched holes and find the axis of symmetry for the following. A part. In this figure, we have to find axis of symmetry. That is, where should we place the mirror so that we get symmetrical figure. So if you place mirror here, then you will be able to get copy of this image on the mirror. So this is your vertical line of symmetry. B. Again, we have these punched holes, and if you fold it this way from this fold, then if you punch here, you will get symmetrical punches. So in this case, this diagonal is axis of symmetry. Now for C, if you place your mirror here, then you will see on the mirror this image. Therefore, this is the line of symmetry. This time we have horizontal axis of symmetry. Line of symmetry or axis of symmetry is the same thing. Again, if we fold this paper like this, using this fold, then if we punch here and here, when we open it, you will get your punches here. Therefore, in this case, we again have horizontal line of symmetry. In this E part, we can have 1, 2, 3, 4 lines of symmetry, or again axis of symmetry, because if you see this vertical one, you will be able to get these punches on this side. Again, if you have these punches, you will be able to get them back with this horizontal line of symmetry. F part, well, these punched holes can only be obtained when we have vertical line of symmetry. That is, if you fold it like this and you punch here and here, and when you open it, you will get other half of this punched hole and one from this. That's for F. Figure G. With vertical axis of symmetry, you will be able to make this punched hole appear on this side as well. Again, with horizontal line of symmetry, you will be able to get this punched hole on this side. For I, we have 2 punched holes. If you fold it like this, using this fold as your axis of symmetry, you will be able to get these 2 complete holes. Here, if you fold from this fold, then when you open it, you will get this punched hole on this side. For K, we can have 2 lines of symmetry. That is, for these, this is your axis of symmetry, and for these, this horizontal one is your axis of symmetry. It is very similar to this. Only difference is that we have extra 2 punched holes. Here, we will have this punched hole and this punched hole, and when you will open it, that is this circular figure, this punched hole can be seen which appeared from this punched hole and this one from half of this. So these figures are more understandable when you do them practically, but with practice you are able to determine axis of symmetry by visualizing only. So that is your first. Second, given the lines of symmetry, find the other holes. Here we are given with punched holes in these figures, and these are axes of symmetries or lines of symmetry, whatever you want to call them, and you have to find other holes that these lines of symmetry will create. Or in other terms, if you place mirror on these lines, then what will be the image formed? That is, where will be the other holes on that image will be. So first one is simple. Just visualize, here we have mirror. Then you will see these lines as these, and this will be like here, as we have shown in figure A. Again, placing mirror here, or the other way is that fold this paper from this and punch a hole here, and when you open it, you will see hole here. Well, such type of questions we also did in previous class, so it is just a revision of that. In C, when you will open it, this punched hole will appear here as in C. The same thing was done in previous question as well, but that was a bit complicated. Now here, when you will open this semicircle, if you fold it from here, it will become a semicircle. You punch a hole here, you open it, you will find a hole here. That is what this question is asking for. Again, if you fold it, it will become semicircle. You punch hole here and here. When you open it, you will find holes here and here. Obviously, here will also be holes, but we are just showing the other holes. Here we will have hole, here we will have hole as well. So with this, E is completed. and that is second. Question third. In the following figures, the mirror line, that is the line of symmetry, is given as a dotted line. Complete each figure performing reflection in the dotted, that is mirror line. You might perhaps place a mirror along the dotted line and look into the mirror for the image. Are you able to recall the name of the figure you complete? In this question, we are required to find two answers. First of all, we will have to complete the figure that will be placed on the mirror, or that will be formed in the mirror, but we will visualize it because we have done quite a number of examples of this concept, and we have to name the figure thus formed. So A, we have here, well, as we have also studied in previous class, that you have to take the distance same time, because plane mirror always show an image equidistant from the mirror. So it will be equidistant from here. So first line will be like this, and then we have vertical one, we will have vertical one, and again touching to mirror. So if you see here, it is a square. That's A. B, well, again this angle will be formed because reflection is happening, and it will touch like this. As we have B, thus it is a triangle. Here, this point will be somewhere here, and you have to connect this. Obviously it will be somewhere here. You will connect it and you will get this figure, and it is a rhombus. Here we have a semicircle. Completing it makes a circle. Again 1, 2, 3. Other side will also have 1, 2, 3 like this, and you will get a pentagon because it will have 1, 2, 3, 4, 5 sides. Here this point will be here, this point will be here, this will be here, and this will be here. You connect it, you will get this figure, and it will become octagon because it has 8 sides. So in this way you visualize it. That is, you cannot always take mirror with yourself. When the figures become complicated, you have to consider these points, as we have also explained in previous standard. That is third. Fourth, the following figures have more than one line of symmetry. Such figures are said to have multiple lines of symmetry, as we have in this. So these have multiple lines of symmetry. Identify multiple lines of symmetry, if any, in each of the following figures. So the first one, we have multiple line of symmetry in this because we have 3 sides. So 3 lines of symmetry are there. One is crossing from this and from this vertex like this. Another from this vertex and from this intersection. Third one from this intersection and this vertex. That is, we can place mirror 3 ways and our symmetry will remain intact. That's first. For B, we have 2, horizontal one and vertical one, as we have shown here. For C, again, we have 3 vertex, 1, 2, 3, like this. That's for C. D, one is like this and another one is like this. Well, we can't have like this because this curve will be here, which will make it asymmetrical. Therefore, we have 2 only for D. For E, we have 4 again, 2 from these diagonals and 2 from these centers, like we have here. Here, we have only 1, that is vertical one. We cannot have this one because this curve will not be formed. That's for F. For G, again 4. Vertical, horizontal and diagonal, we have 2, like this. Here we have 6, like this. 1, 2, 3, 4, 5 and 6. So this is more of a practical question. You will get it more if you'll do yourself. That is fourth. Question 5. Copy the figure given here. First copy it. Take any one diagonal as a line of symmetry and shade few more squares to make the figure symmetric about a diagonal. Is there more than one way to do that? Will the figure be symmetric about both the diagonals? So we have to check it. In this question, we have to take diagonal and we have to make the figure symmetrical about diagonal. So what are diagonal? You know this, connecting opposite to vertex. So this is one diagonal, this is another diagonal, and initially we have this figure. So if you first put this diagonal as line of symmetry, then we have this one given, we will have here. Therefore we painted this box because this will be reflection. We have here, so its reflection will be here because this line is there like this, and this thing will be here. Again, its reflection will be here, that's why we have to construct this one, and its reflection will be here. Therefore this thing came. Therefore this diagonal makes this figure symmetrical. Again, without changing these boxes that we have already drawn, if we draw this diagonal and just forget this one for the moment, you will be able to see that this figure maintains its symmetric nature. Therefore, yes, the figure is symmetrical about both the diagonals. That's first. And another part was, is there more than one way to do that? Well, yes, there is. If you have already drawn symmetrical figure that holds true for these diagonals, then the same figure also holds true if you have vertical line of symmetry and horizontal line of symmetry. That is, we get symmetric figure if we place mirror like this, that is vertically. You will be able to see this portion on the mirror if you place mirror here, and again if you place your mirror here, you will be able to see this portion on the image like this. That is, it maintains its symmetric nature. So therefore there are total 1, 2, 3, 4. Therefore there are total 4 axes of symmetry. That is fifth. Question 6th. Copy the diagram and complete each shape to be symmetric about the mirror lines. This question we have already done in our previous standard. Just for revision, we have these images, and suppose this is your plane mirror. You have placed your mirror like this. Then on mirror you will be able to see image like this, and you know how it came. Let's revise it. Well, the reflection will start from this point and it is going diagonally to this point, so it will go like this as we have already drawn here. Again it continues till how many vertices? 1, 2, 3. So 1, 2, 3, it will end here. Then we will have to drop it to its opposite vertex. This, consider this is a square, its opposite vertex, because here it is also connecting and it is going 2 lengths, 1, 2, therefore 1, 2. Therefore this is completed. Again here, well, we will not have image from here because it is one distance away, so it will start from here like this, and it will go up to 2 distances because we have 1, 2. Therefore it goes 1, 2. Then it goes to opposite vertex, 2 lengths, opposite vertex, 2 lengths. So in this way image has been formed. For B, we have this one and we have to use 2 axes of symmetry, vertical and horizontal. Let's first use horizontal. So we will have image here like this as we have shown here, and you know how it came. But when you will place your mirror here, just imagine that mirror is placed here, you will have image here. Therefore this one for vertical line of symmetry. You will not have image here by any means. That's B. Here again 2 axes of symmetry. Let's consider vertical first. So you will have curve like this as we have shown here, and for horizontal it will be like this, and again here no image will be formed. Let's see. Now this is a bit complicated. Here image will start from here and it goes with this angle, therefore image will also go with this angle like here, and this distance will be equal from this to this. Then it goes like this, then it has to go like this. Again it is coming closer now from here like this, and it is again touching this point. So in this way, you make your images without actually using mirrors, and you can confirm after constructing it. Just place your mirror like this and see whether the image that you have constructed appears on the mirror. With practice, you will get it more. That is 6th. Question 7. State the number of lines of symmetry for the following figures from A to J. For an equilateral triangle, what is an equilateral triangle? Equal angles and equal sides. We have obviously 3 lines of symmetry already did in previous standard. So this, that is going from each vertex. Second isosceles triangle, 2 sides are equal, base side is different, and these angles are equal, only 1 line of symmetry. Third, scalene triangle, it means 3 unequal sides. So this is a scalene triangle and we have 0 because you will not get any symmetric image formed on mirror by placing the mirror in any direction. A square, this is square, it has 1, 2, 3, 4 lines of symmetry. Then we have rectangle, again it has 2, 1, 2. It do not have diagonal wise because your image is not formed on the mirror. It is asymmetrical in nature, therefore only 2. Now a rhombus. Now what is a rhombus? It's a flat shape with 4 equal straight sides. These are equal, like square. A rhombus looks like diamond. This is diamond shape. All sides have equal length. Same thing. Opposite sides are parallel. That is, this side is parallel to this and this side is parallel to this side. So in case of rhombus, we have only 2 lines of symmetry. A parallelogram. For a parallelogram, it is similar to rhombus. That is, opposite sides are equal. So this angle equals this angle equals this. In case of parallelogram, we have 0 line of symmetry. Place mirror like this, you will not be able to get symmetric image. Then a quadrilateral. Well, a quadrilateral can be anything. It can be square, a rectangle, but since it has not given us the exact name, then we can consider parallelogram as this. It has 4 sides, but it doesn't have any axis of symmetry. A regular hexagon. Now hexagon is having 6 sides. What does regular mean? That is equal sides and equal internal angles. So we have studied one concept in this chapter, that a regular object will have as many as axis of symmetry as many as sides. So in case of hexagon, we have 6 sides, therefore 6 lines of symmetry are present. 1, 2, 3, 4, 5 and 6. A circle, well, we have studied it many times. It has infinitely many because it crosses from the center and all lines of symmetry are its diameter and they can be endless. So with this, 7th is completed. 8th, what letters of the English alphabet have reflectional symmetry? That is symmetry related to mirror reflection about a vertical mirror, a horizontal mirror. C, both horizontal and vertical mirrors. Exactly same question has been repeated in this chapter as well. We have already done this question in previous class. So these are English alphabets and we have to find which letters have vertical mirror, that is vertical line of symmetry. So A has vertical line of symmetry, and we can see H has, because if you place mirror here, you will be able to see exactly same figure as we have of H. Then I, then we have M, then O, T and U, V, W, X and Y. So these are vertical mirror symmetry. A horizontal one, if you place mirror like this, then symmetry is maintained for B, C, D. Then you have H, then I, K, O, and then you have with X, that is horizontal mirror. Now see, both horizontal and vertical mirrors. Well, we have O, then we have X, I and H. Therefore 4 alphabets have both vertical and horizontal ones. And in previous standard we had a question that Which alphabets do not have any line of symmetry? Well, as you can see, F, G, J, L, N, P, Q, R, S, and Z will not have any line of symmetry in case of English alphabets. That is 8th. 9th, give 3 examples of shapes with no line of symmetry. Well, we have already studied in this exercise that quadrilateral, scalene triangle, and parallelogram can be 3 examples which do not have any line of symmetry. This is quadrilateral, it can be of any shape but having 4 sides. In this case, unequal sides, therefore no line of symmetry. Again, scalene triangle, since all the 3 sides are not equal in length, therefore no symmetry can be performed, and in case of parallelogram as well. So that is 9th. 10th, what other name can you give to the line of symmetry of an isosceles triangle? Be a circle. So in case of an isosceles triangle, let's remember what is median. In geometry, a median of a triangle is a line segment joining a vertex to the midpoint of the opposite side. That is, this is the base, and these are equal sides in case of isosceles triangle, and these base angles are also equal. That's all about isosceles triangle. Now, median in this case is on the base, take the middle point, draw a perpendicular which touches, or simply just draw a line which touches this vertex, that is opposite vertex, that will be median. And we have also studied in this chapter that from here itself, from here only, line of symmetry goes. Therefore, another name for line of symmetry in case of isosceles triangle is median. That's for A. And for B, a circle. Well, it has infinitely many line of symmetries. As we have also discussed in previous questions, that a diameter is a line of symmetry in case of circle. And obviously half of diameter is radius. So in geometry, a diameter of a circle is any straight line segment that passes through the center. That center, and whose endpoints lie on the circle. These are endpoints. It can also be defined as the longest chord of the circle. Again, diameter is the longest chord as well. That we have also studied in previous classes. That's B. And with this, last question is completed, question 10th.